So, actually, this is in continuation of what we learned in the previous class. We know that the equation of a line is written in the form y is equal to mx plus c, where m is the gradient of the line and c is the y-intercept. So when you look at this first question here, it says write down the equation of the line. So we are trying to write the equation of a line with this given information. So it says the gradient is 3 and the y-intercept is 4. Gradient is 3 and the y-intercept is 4. So I just want to put down the information first. The gradient is 3. We call that as m. So m is 3. The gradient is 3. And the y-intercept, which is c, is equal to 4. So you have m, you have c. So once you know these two values, we can straight away go ahead and write the equation of the line. So the equation of the line is y is equal to mx plus c. That is y is equal to m is 3, so 3x plus 4. So that is the equation of the line. Now, if they say write the equation of the line in the general form, you would get the x term and the y terms both on the same side, right? Like I could shift this 3x to the left side, so it will become minus 3x. So it would be minus 3x plus y is equal to 4. That will be the general form. Now this is the gradient intercept form. So we have the equation of the line in the gradient intercept form. Y is equal to mx plus c. Let's try question C next. So in C, it says the gradient is minus 1. So immediately I write m is equal to minus 1 and c is equal to 1 by 3. So we know the values of m and c. So I will write y is equal to mx plus c is the equation of the line in the gradient intercept form. And I know the values of m and c. So y is equal to minus 1x plus 1 by 3, which is the equation. Just in case you need to convert this into the general form, I would say multiply each term by 3. So multiply, it's only optional because nothing is being said in the question. They said just get the equation. Multiply by 3, multiply each term by 3. This is just to convert it into the general form of a straight line. So that's going to give me 3y on the left side because I am multiplying this by 3. So that will make it 3y. Then I multiply the second term, this by 3, which will give me minus 3x is equal to minus 3x. And the last term, 1 by 3, I multiply by 3, which will give me just plus 1. That's if you want to write it in general form. But we say in the general form, it should look like ax plus by is equal to c. So I shift it to the left side, so I get 3x plus 3y is equal to 1 is the equation. All right. Oh, the next one, look at that. It says find the equation of a line whose gradient is 0 and the y-intercept is 5. So I'm going to write that information. M is equal to 0 and c is equal to 5. So y is equal to mx plus c. Y is equal to 0 times x plus 5. Therefore, I get y is equal to 5. So that's the equation. Gradient is 0. We know that if the gradient is 0, it's a horizontal line. It's a line parallel to the x-axis. So how would it look like? I have the x-axis and the y-axis drawn. That's origin 0. Now this is a line. Y is equal to 5. So y is equal to 5, which means it will have y-intercept 5. So this is going to be a line, a horizontal line passing through y is equal to 5. So this is the equation. This is the line. Y is equal to 5. The line is like this, the horizontal line, which is intersecting the y-axis at 5. A line which is parallel to the x-axis. It's a horizontal line. Okay. Let's go to question number 2, the alternate questions you are supposed to do for practice. So copy down those questions and do them. Okay. So now if you go to question number 2 there, it says a straight line has gradient 1 by 4 and y-intercept negative 6. So let's put down those information. Gradient m is equal to 1 by 4. Gradient is 1 by 4. Y-intercept is c. C is equal to negative 6. So the equation is y is equal to mx plus c. Y is equal to 1 by 4x minus 6. Okay, that's the equation of the line in the gradient intercept form. So we found the equation of the line in the gradient intercept form. Now there is a sub question to it, the B part of it. So this was A part and now the B part. It says find the x-intercept of the line. Now that's something which you need to remember. To find the x-intercept, you make y is equal to 0. And to find the y-intercept, you make x is equal to 0. So here the question is to find the x-intercept. So we are going to make y is equal to 0. So remember this. If I have to find the x-intercept, you should make y is equal to 0. So we're going to say make y is equal to 0 into the equation. So I get 0 is equal to 1 by 4x minus 6. I rearrange it, so I get 6 is equal to 1 by 4x. Therefore, x is equal to multiply both sides by 4, which will give me 24. So that's the x-intercept. 24 is the x-intercept. X is equal to 24, the x-intercept. As a coordinates, I would say it is 24, 0, but x-intercept is 24. Okay. So that's a small result we need to remember. To find the x-intercept of a line, we should make y is equal to 0, and to find the y-intercept of a line, make x is equal to 0. Okay. The next question, set of questions, it says, find in the gradient intercept form the equation of the line which has a gradient 2 and passes through 1, 8. So you want to find out the equation of a line in the gradient intercept form. Of course, we know it. The gradient intercept form is y is equal to mx plus c. That is the equation of a line in the gradient intercept form. But they said the gradient is 2, which means we already know what m is. So m is 2, I know, but c is missing. I don't know. I need to find that c. So for the time being, I'm going to keep c as c itself, and I sub in the value of m. So I'll get y is equal to 2x, mx. M is 2, so 2x plus c. So that's the equation of the line for the time being. But of course, we know c is missing. We want to find out what is c. For that, they say that this line passes through the point 1, 8. This line passes through the point 1, 8. So which means I can put x is equal to 1 and y is equal to 8. I replace x with 1 and y with 8. X is 1, y is 8. Because the point is 1, 8. We say it passes through the point 1, 8. Therefore, the line passes through the point 1, 8. Therefore, its x value is 1 and the y value is 8. So I'm going to plug it in. I substitute these values. So I'll get 8 is equal to into this equation. So when I replace it, 8 is equal to, that's my y value, is equal to 2 times x. X is 1 plus c. So I solve for c. C is equal to 6. Once you get the value of c, put that back in. Therefore, y is equal to 2x plus 6 is my final answer. I replace c with its value. Let's look at the next one. It says, find the equation of a line in the gradient intercept form, in the y is equal to mx plus c form. When this is given to you, when it says when the line has a gradient 5 and it passes through minus 3, minus 1. So the required line has a gradient m is equal to 5, but c is missing. I need to calculate. I need to find that value. So m is 5, I know. So what's the equation of a line in the gradient intercept form? We know the format. It's y is equal to mx plus c. That is the format of the line. Y is equal to mx plus c. But m is 5. So that's going to be y is equal to 5x plus c. y is equal to 5x plus c. Of course, c is missing. To find this c, they give you another information that this line passes through the point minus 3 comma minus 1. So I will say this line passes through the point minus 3 comma minus 1, or minus 3 comma minus 1 lies on this line, which means its x value is minus 3. Therefore x is equal to minus 3 and y is equal to minus 1. So I can now make x as minus 3, y as minus 1. So what does this become? X is minus 3, y is minus 1. So this is going to be minus 1 is equal to 5 times minus 3 plus c. That's negative 1 is equal to negative 15 plus c. Therefore, c is equal to negative 1 plus 15, which is going to be 14. So I got the value of c. Put that back in. Therefore, y is equal to mx plus c. 5x plus c it was. 5x plus c is now 14. So that's the required equation. So we found the equation of the line. The next question, when you see there's a small difference there, the gradient is given to be 0. So that makes it a little bit more easier for us to handle the question. If the gradient is 0, that means it's a horizontal line. And every horizontal line actually looks like y is equal to c. That's it. Y is equal to c because the gradient is 0. So, and c is the y-intercept, right? Okay, so that's all what you need to find here. So, but anyway, let's work it out and see. So this is y is equal to mx plus c, and m is given to be 0. So y is equal to c. That's the given equation. And then I need to find what the c is. C is, of course, the y coordinate here, which is 4. So y is equal to 4. If I write, I have my answer. Or if you want to follow the usual way of doing it, y is equal to c is the equation where c is to be found. And then we say minus 2 comma 4 lies on it. Therefore, x is equal to negative 2 and y is equal to 4. So I can replace x with negative 2 and y with 4. So it's going to be 4 is equal to c. So basically then c turns out to be 4. Therefore the equation is y is equal to 4, and that's our answer. So we could have done this directly because if you look at this question here, it says the gradient is 0. So the moment they say gradient is 0, you should realize that the line is a horizontal line. There are two kinds of lines we have learned. One is called a horizontal line and the other one is called a vertical line. For a horizontal line, the gradient is 0, and for a vertical line, when it is like that, parallel to vertical line is a line, is y-axis, and any line parallel to it is called a vertical line. So it will look like this. And for every vertical line, its gradient is undefined. You know the reason, because it's rise over run, and for a horizontal line, the run is actually 0. So it's going to be undefined. And for a horizontal line, this is a line which is parallel to the x-axis. The gradient is 0, and its equation is always going to be y is equal to c. Y is equal to the y-intercept. So which is just the y coordinate here, 4. So y is equal to 4. You could directly write that answer. We're going to look at another question based on it here. Read this question. It says, find in gradient intercept form the equation of the line which is parallel to the line y is equal to 3x plus 4 and passes through the point 2 comma 4. So here the change is that they did not give you the gradient. So if you look at the previous question, they talk about the gradient. Look at this question again. It says find in gradient intercept form the equation of a line which has gradient to and passes through the point. But when we come down to this question here, they still want the equation of a line in the gradient intercept form, but the gradient is not given to us. They said instead it is parallel to another line. So we are looking for a line which is parallel to the given line. So what I would do is I will copy my given line. So let's copy down the given line first. The given line is y is equal to 3x plus 4. And this line is already in the gradient intercept form. It looks like y is equal to mx plus c. So when you compare these two equations, we know that the gradient of this line is 3. So the gradient of the given line is 3 and the required line is a line parallel to it. Now how would it look like? If I try to draw the graph of it, it's not the exact graph. I just want to show a pair of parallel lines. So I have a pair of parallel lines like this. Okay, these two lines are parallel. And if these two lines are parallel, they are going to have the same gradient. The gradient of both the lines will be, because they have the same inclination, they are parallel lines. So they are equally inclined, basically to the x-axis. So both the lines are equally inclined. So that means they have the same gradient or they have the same slope. And I know the gradient of the given line. The given line has a gradient m is equal to 3. So naturally, the parallel line, the required line, will also have the same gradient. So I'll say for the required line, also the gradient is going to be the same. Since the required line is parallel. Now, do we have to write this long sentence? No, not necessary. You could just write therefore m for the required line is 3. Okay, since the required line is parallel to the given line, the gradients are same. I'm just writing the reasoning behind it. Gradient will be the same. Gradient will be the same. Therefore, m of the required line is 3. Of course, c is still missing. We need to find c. We put this into the standard format for finding the equation of a line. Y is equal to mx plus c. Y is equal to mx plus c is the equation of a line. And we sub in the values which we know into this, which is y is equal to 3x plus c. And we are stuck here because we don't know what c is. Now, this becomes similar to the previous question. You have the gradient, but the c value is missing. And to find the value of c, they give you an additional information. They said this line passes through the point 2, 4. So I'm going to put in that information. I will say this line y is equal to 3x plus c passes through the point 2, 4. Therefore, it must satisfy its equation. So I'm going to write that statement here. 2, 4 lies on this line. Lies on it. Therefore, x is equal to 2 and y is equal to 4. So 4 is equal to 3 times 2 plus c. Therefore, c is equal to 4 minus 6, which is negative 2. Therefore, the required equation is y is equal to 3x minus 2. So we talked about one result here. If two lines are parallel, then their gradients are going to be the same. That's the result we used in this particular question. So we have one more question like that. Quickly, let's work out that question. And then we have a slightly different idea. So it says here again, find the equation of a line that is parallel to this given line and it passes through the point 8, negative 3. So I'm going to start with the given line. I'll say the given line is y is equal to negative 1 by 4x minus 2. That's the given line. And so I can write its gradient because it looks like y is equal to mx plus c. It matches with the standard format. So m is equal to negative 1 by 4. Therefore, m of the given line is negative 1 by 4. Now I'll say therefore for the given line, for the required line, also the gradient is going to be the same. For the required line, m is going to remain the same because they are parallel. You could just write that reason in brackets, because the lines are parallel. They are parallel. Okay, so I know the value of m, so I'm going to write the equation of the line, which is y is equal to mx plus c, y is equal to negative 1 by 4x plus c, but c is missing. And to find this c, they gave you an additional information that the line passes through the point 8 comma minus 3. So I'm going to write that bit of information here. It passes through, or minus 8 comma negative 3 lies on it. Therefore, x is equal to 8 and y is equal to minus 3. So I replace y with minus 3 and x with 8. Negative 3 is equal to negative 1 by 4 times 8 plus c, which implies negative 3 is equal to negative 2 plus c. Therefore, c is equal to negative 1. Got the value of c, which I put back into my original equation. Y is equal to minus 1 by 4x plus c, but c is now minus 1. That's the equation of the line in the gradient intercept form. Now, if they wanted the general form of the line, I would have said multiply throughout by 4 and then rearrange it in the form ax plus by is equal to c. The next question is slightly different. This is a different situation altogether. Here what we need is, we have a line given to us and then another line which is perpendicular to it. So there are two lines here. The green line is the given line. Let's say that's a given line. That the green one is the given line. And the pink one is the required line. I'm going to mark the gradient of each of these lines. Let's say m1 is the gradient of the green line and m2 is the gradient of the pink one. If these two lines are perpendicular, like this, if they are perpendicular, then the product of the gradients will always be minus 1. Now, we are not going to prove this. For the time being, we are going to accept this result, and the proof becomes a bit more easier when we talk about trigonometry later on. So at the moment, we are going to accept this result. What you could do is, you could just verify these results, like actually draw two lines which are perpendicular to each other, pick up 2 points on the first line, calculate its gradient, pick up 2 points on the second line, calculate its gradient, and you multiply them. You take the product of the two gradients, m1 times m2. It will turn out to be always negative 1. The product of the gradients of two perpendicular lines will always be negative 1. Now, that way of checking whether the answer is correct or the result is true is called verifying, not actually proving, it's verifying. Proof, as I told you, you need a bit of trigonometric idea, which makes the proof a little more easier. I could also say that the gradient of one of these lines, m2, would be negative 1 by m1. Because m1 into m2 is minus 1, I can divide both sides by m1, so I'll get m2 is equal to negative 1 by m1. Or in other words, I could say gradient of one of the lines will be the negative reciprocal. See, you have a negative sign on the right side, and instead of m1, it is 1 by m1. So the gradient of one of the lines will be the negative reciprocal of the gradient of the other. So that's how we calculate it. Okay. So if you know the gradient of one line, for example, if I know m1, one of the lines is 5, and if the two lines are perpendicular, gradient of the second line would be negative reciprocal, negative 1 by 5. Okay. Another example. Suppose I have one of the lines M1 with a value of negative 2 by 3. Negative 2 by 3. It's already a negative number. A perpendicular line will have a gradient which is negative reciprocal. So it's already a negative number. So when I say negative reciprocal, negative of the negative number makes it positive but reciprocal. So 2 by 3 becomes 3 by 2. In general, if I say M1 is A by B, then M2 would be negative B by A. One more example quickly. If M1 is negative 2, M2 would be its negative reciprocal. It's already a negative number. So when I say negative reciprocal, negative of a negative number makes it positive. And 2, its reciprocal is 1 over 2. Alright, so that's basically the idea. If two lines are perpendicular, the product of the gradients will always be minus 1, or rather I could say gradient of one of them will be the negative reciprocal of the other. Alright, so let's try this question here. So I'm going to leave that part which we discussed here as it is and work out this question. So there is a line given to us. So we're going to start with the given line. The given line is y is equal to negative 1 by 2x plus 3. That's the given line. Y is equal to negative 1 by 2x plus 3. Which is in the standard format y is equal to mx plus c. Therefore, m is equal to negative 1 by 2. So we know the gradient m is equal to negative 1 by 2, gradient of the line. This is gradient of the given line. I'm going to call it as m1 because there are two lines. Let this be m1. Now I want to find out the gradient of a perpendicular line. So I'm going to say for the perpendicular line, if it was parallel, we would have kept the gradient the same. For the perpendicular line, we know that the gradient is going to be negative reciprocal. So M2 would be negative reciprocal. But you look at the first gradient, it's already a negative number. So negative of negative is going to be positive but reciprocal. The original gradient is 1 by 2, so its reciprocal is 2 by 1. So this is going to be 2 by 1 there, 2 by 1. So that's my M2. Or rather, I could just call it as 2. Positive 2 by 1 is just 2. That's M2. So the equation will be y is equal to mx plus c, y is equal to 2x plus c. But we know the value of a point. You know the coordinates of a point there. We'll say 3, 5 lies on it. Therefore, y is equal to, now I'm going to replace x with 3 and y with 5. So 5 is equal to 2 times 3 plus c. Therefore, c is equal to negative 1. Therefore, the equation is going to be y is equal to 2x minus 1. That's a required equation. Alright, so practice all these questions and you need to do the alternate questions as well. Okay.